Welcome. This is the Cisco CCNA ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. Moving on, we have our IPsec. IPsec consists of a few different layers. There's two main phases, phase 1 and phase 2, and so we're going to have to look at the different forms of those phases. There's protocols with things like AH, ESP, SA, and IKE, and again we're going to explain all of those coming up. So IPsec is a IETF standard defining how VPN will secure data traffic across the network. There are four main functionalities that IPsec VPNs are made to actually handle. Confidentiality, that's going to be our encryption. Integrity, that's using hashing algorithms to ensure packets are not molested. We have our original authentication, and that will be using our IKE protocol, or our Internet Key Exchange protocol, to authenticate source and destination. We also have the ability to use Diffie-Hellman for our key exchange. Our Diffie-Hellman are also known as DH keys. So again, our IPsec framework will look at the IPsec protocols, AH, ESP, or ESP plus AH. Our confidentiality will be our encryption. We have our integrity, that's going to be our hashing functions. We have our authentication methods, our pre-shared key versus a RSA-based key. And then we have our Diffie-Hellman type keys for our key exchange. So IPsec is not bound to any specific rule for our communication. It is very flexible. So in that regard, let's look at our first section. I like how this is all kind of slanted. AH is basically our authentication header, or that's AH. This is our encapsulation security protocol, ESP. So we can choose what to encrypt or what to encapsulate. Are we encapsulating the header or the entire packet? Or we can do both. So we can choose AH or ESP to establish the other locations. This is the building blocks of the rest of our packet. If we are looking at AH, it's appropriate only when confidentiality is not required or permitted. If confidentiality is required, we need to use ESP. That provides both confidentiality and authentication. Once we've set which IPsec protocol we're going to use, then we have to talk about confidentiality. Again, that's going to be the level of encryption that will be used. And again, the degree of confidentiality will depend on the encryption algorithm and the length of key. What keys do we want to use? Triple des, weak keys should not be used. So we should be using things like AES or SIL. AES has 128-bit, 192-bit, 256-bit, and more. Our SIL has around 160-bit base keys. After we've decided what confidentiality protocol to use, we need to look at our integrity protocol. Normally we're going to be looking at some form of hashed message authentication code, HMAC. This will verify data integrity. The two main algorithms are going to be either MD5 or SHA. MD5 is the least secure of the two. SHA is the more secure. And right now, the SHA default key is going to be 160-bit in length. Once we've decided the integrity key, we can look at the authentication. And again, the two main types are pre-shared key or our RSA-based key. If we're using pre-shared key, it's easy to configure, but it doesn't scale very well. And we have to configure this per peer. If we're doing RSA, we can authenticate using digital certificates to identify our peers. However, each peer must authenticate to its opposite peer before the tunnel is basically considered secure. So there is more configuration with the RSA. Lastly, we have our Diffie-Hellman type keys. We have different DH standards, one being the least secure And our higher ones like DH21, 24 are more secure. Realistically, DH14 is pretty well, is one of the more common ones. DH1, 2, and 5 are not really used anymore. DH groups 14, 15, 16, they use larger keys. For example, DH14 has a key size of 2048 bits. However, larger DH groups like 19, 20, 21 have key sizes of 256-bit, 384-bit, and so forth. However, DH groups of 19, 20, 21 will use the elliptical curve cryptography-based system, or ECC. This helps reduce the time needed to generate keys. Where DH groups 14, 15, 16 do not use ECC, they use other forms of key exchange. And that is it for this module. If you got any questions or concerns, please reach out. Thank you.